Welcome, space friend, to another journey with the Sleepy Equation, a place where the biggest questions of the universe are gently unwrapped. Tonight, we're going to explore an idea, a whisper from the edges of physics that suggests time itself might not exist out there. It's a thought as vast and quiet as space itself. So wherever you are, whatever hour it has grown to be, make yourself comfortable. Before we launch into the starry void, I'd be so grateful if you'd give this video a gentle like. It helps this little channel reach more. And if you'd like to join me for more journeys into starlit science, consider subscribing. It's always a comfort to see this community growing. Let's begin. To understand this, we must imagine ourselves stepping away from Earth, feeling its pull lessen, watching it shrink beneath us. We're going to a place of perfect silence and profound darkness, a place between stars. Out here, there is no air to carry sound, just the endless, velvet black, punctuated by distant, unwavering pinpricks of light. The first clue that time is not what we think it is came from a man with wild hair and a quiet mind over a century ago. His name was Albert Einstein. With his theory of relativity, he didn't just change physics, he quietly unraveled our common sense understanding of the universe. He showed us that time is not a universal constant. It is not a steady, ticking drumbeat for all of creation. Instead, he described time and space as a single, woven fabric, a space-time continuum. And this fabric, he said, can be stretched and warped like a soft, elastic sheet. Think of it this way. Imagine that space-time is a still, calm pond. Now place a heavy object in the center of it, a large, smooth stone. The stone creates a dip, a curvature in the surface of the water. This is what a planet or a star does to space-time. It creates a gravity well. Now, if you were to roll a tiny marble, a little spaceship perhaps, around the heavy stone, its path would curve. It would orbit the stone, not because the stone is pulling it magically, but because it is simply following the curved path of the pond's surface. This is gravity, not a force, but a consequence of geometry. But here is the part that changes everything. Einstein said that this curvature doesn't just affect the paths of objects, it affects time itself. The closer you are to a massive object, the deeper you are in its gravity well, the slower time flows. It is not a mechanical slowing, it is a fundamental property of the universe. Time itself stretches out. This isn't just a theory, it is measured every single day. The GPS satellites that guide your car, orbiting high above the Earth, are less deep in Earth's gravity well than we are. For them, time actually passes a tiny, tiny bit faster than it does for us on the surface. If their incredibly precise clocks were to constantly corrected for this effect, your navigation would be off by miles within minutes. The clocks in orbit literally run at a different rate than the clocks on the ground. Time is not absolute. It is relative. It bends. So, if time is fluid, if it can be stretched and slowed by gravity, then what happens where there is almost no gravity at all? Out in the deep, empty space between galaxies, where the nearest star is so far away, it's merely a speck of dust in an immense cathedral. What happens to time there, in the ultimate quiet? Let's drift there now in our minds. Let's imagine we've traveled for millions of years, away from any galaxy, any star, any atom of dust. We are in the true void. The temperature is just a few degrees above absolute zero. There is almost nothing here. And in this near-perfect emptiness, the curvature of space-time is almost perfectly flat. The pond is still. There is no dip, no well, no slope to fall down. In this place, a clock would behave differently. With no gravity to slow it down, would it run at its fastest possible rate? But fastest compared to what? If there is no other clock to compare it to, what does fast or slow even mean? Here, at the farthest reach of isolation, the very idea of timekeeping begins to feel strangely hollow. Without change, without event, without the rhythmic pull of gravity, does time have any meaning at all? Or does it simply fade away, like a forgotten whisper? It is a thought as vast and quiet as the void itself. So, we find ourselves adrift, floating in that profound silence in the space between spaces. The concept of a minute or an hour starts to feel small. All the rush and hurry of the world down there, all the deadlines and alarms, are just a local phenomenon, a story we tell on our little planet. Out here, there is no rush. There is no late. There is only is. But our journey into the heart of timelessness is just beginning. To go deeper, we must meet another ghost in the cosmic machine, a theory that governs the impossibly small, just as relativity governs the impossibly large and fast. This is the world of quantum mechanics. And if relativity made time fluid, quantum mechanics asks us if it's even real at all. Picture the universe not as a collection of things, but as a collection of events, of happenings. A star is not a noun, but a verb. It is nuclearly fusing. A planet is orbiting. You, lying there, are breathing, heart beating, thinking. Now, at the very smallest level of reality, these events are not smooth and continuous, like the flow of a river. They're jumpy, choppy. They happen in tiny, discrete packets. A light wave, for example, is made of photons, little particles of energy that jump from one place to another. They don't smoothly travel, they disappear here and appear there. This is the quantum world, a world of probabilities and leaps. And in this world, some of the most profound theories suggest that time itself might not be a fundamental ingredient. Think of the universe as a vast, interconnected network of relationships. What matters is how things are related to each other, the distance between particles, the forces they exert on one another, the order of events. But the idea of a universal clock ticking in the background, a clock that all particles obey, that clock might not exist. The most elegant equations of quantum gravity, the theories that try to marry Einstein's relativity with the quantum world, often work perfectly well without time as a variable. It simply drops out, like a scaffolding that was used to build a universe but is no longer needed once the building is complete. These theories suggest that time might be an emergent property, a story that emerges from a deeper, timeless reality, much like temperature emerges from the frantic jiggling of atoms. A single atom doesn't have a temperature. Temperature is a story we tell about the collective behavior of trillions of atoms. In the same way, time might be a story we tell about the relationships between events. We remember the past and anticipate the future because of cause and effect, because of the way energy spreads out and entropy increases. But at the most fundamental level, the universe might just be, all at once, forever. This is a thought to not clutch too tightly. It's a feather. Let it float. It's the idea of the block universe, where the past, present, and future all exist simultaneously. The day you were born is still out there in the space-time continuum. The moment a dinosaur took its last breath is still there. And the distant day when the sun grows old and cold is already written into the fabric of things. We simply experience it in a sequence, like a needle traveling along the groove of a record. We feel the music unfold note by note, but the entire symphony is already there on the vinyl. It can make you feel small, perhaps, or it can make you feel free. All your worries, all your regrets, all your hopes for tomorrow, they are all part of this eternal, static tapestry. There is no need to rush. There is only the experience of the moment you are in, the note the needle is playing right now. And right now, the note is the sound of your breathing, the feeling of the pillow against your cheek, the distant hum of the world outside your window, already beginning to fade as you sink deeper into rest. Out here, in our imagined void, these ideas don't feel so strange. They feel natural. The quantum fog and the relativistic curve both point to the same quiet conclusion, that the steady, dependable time of our earthly lives is a beautiful, necessary illusion, a crutch for our human minds, which are built to experience the world in a sequence of cause and effect. We need it to function, to survive, but it may not be the ultimate reality. And just as we settle into this timeless silence, a new question begins to form. If time is not fundamental, then what is? What is the bedrock of reality from which time emerges? The answer might lie not in looking out at the empty void, but in looking back at ourselves, at the one force that gives time its arrow, its irresistible direction. This force is entropy, and it is the final piece of our puzzle. It's a peaceful feeling, isn't it? To let go of the need to measure, to track, to plan, to simply exist like a star or a particle or a quiet thought in the dark. But if time is not the fundamental director of the cosmic play, what is it that gives our lives this undeniable sense of flow? Why do we remember yesterday but not tomorrow? Why does a glass shatter when it falls, but the pieces never, ever leap back up onto the table and reassemble themselves? This is the mystery of the arrow of time, and its answer lies in a concept that feels less like physics and more like a gradual, gentle letting go. This is the law of entropy. Entropy is simply a measure of disorder, of randomness. The universe has a profound and unwavering tendency to move from order to disorder, from concentration to diffusion. It is the cosmic rule that everything, eventually, spreads out. A drop of ink in a glass of water will slowly swirl and diffuse until the entire glass is a uniform pale shade. It will never spontaneously gather itself back into a single, dense drop. This is the second law of thermodynamics, and it is the only physical law that seems to care about the direction of time. Your own body is a temporary, beautiful rebellion against entropy. You are a pocket of exquisite order built from complex molecules organized into cells, tissues, and organs. You maintain this order by taking in energy from the sun, stored in food, and using it to constantly repair the tiny, constant breakdowns that entropy inflicts upon you. But it's a battle that, in the very long run, we all lose. Entropy always increases. It is the universe's slow, inevitable exhale. And this, perhaps, is the true source of time's arrow. Not some fundamental ticking in the fabric of space-time, but this statistical tendency toward disorder. We perceive the past as the past because it was a state of lower entropy. We perceive the future as the future because it will be a state of higher entropy. Our memory, our consciousness, even the very process of aging, they are all consequences of this great cosmic scattering. Think of it like this. Imagine a brand new deck of cards, perfectly ordered by suit and number. This is low entropy. Now, shuffle it once. It's slightly more disordered. Shuffle it 1,000 times. The cards are now in a state of high entropy, a random, messy sequence. The reason you remember the ordered deck is because there was only one way for it to be ordered. But there are millions upon millions of ways for it to be disordered. It is infinitely more likely for things to be messy than to be neat. So when we see a neat, orderly state, we know it must have come before a messy one. That's the arrow. That's time. But here is the quiet, comforting paradox. This arrow only exists for complex systems, for beings like us who are made of trillions of particles and who can remember and predict. For a single, lonely atom drifting in the void we imagined earlier, the concept of entropy is meaningless. It has no order to lose. It just is. It doesn't age. It doesn't remember. For that atom, the past and future are identical. Without a complex, interacting system to experience it, the arrow of time may not point anywhere at all. This brings us to a thought so soothing, it feels like a blanket for the mind. What if time is not a river flowing through the universe, but a river flowing within us? We are the ones who create the flow of time through our perception, through our constant interaction with the world, through our fight against entropy. We are the narrators of the universe, reading the story of increasing disorder and calling it history, calling it our lives. The universe itself, in its entirety, might be static and timeless, a four-dimensional block where everything just exists. But we, as conscious beings within it, are like readers moving through a book. We can't help but experience the story in order, page by page, from the low entropy beginning to the high entropy end. The book itself is complete, but the experience of reading it, that is time. So, the next time you feel rushed or like there's not enough time, remember this. You are not a prisoner on a rushing river. You are a reader immersed in a magnificent, detailed story. And you can, whenever you wish, pause, look up from the page, take a deep breath, and feel the truth of the moment. The story is already written. The pressure is an illusion. All that is real is this single, quiet, eternal now. And in this now, as you lie there, your body is slowly, gently surrendering to entropy for the night. Your thoughts are dissolving from the ordered patterns of the day into the more random, dreamlike patterns of sleep. And as you drift there, on the edge of dreams, we can finally ask the most beautiful question of all. If time is our story, what happens when the storyteller falls asleep? And so we arrive here, at the edge of sleep and understanding, where the final pieces of our puzzle gently click into place. All that remains is the gentle, rhythmic feedback loop of your breath in and out. A tiny, personal entropy engine in the vastness of a potentially timeless universe. We've seen how time dilates under gravity's influence, a curvature in space-time described by Einstein's field equations. We've considered how it might vanish entirely as a fundamental variable in certain quantum gravity theories, like the Wheeler-DeWitt equation, becoming an emergent property rather than a primary ingredient. And we've seen how the psychological arrow of time, our unshakable sense of past and future, is likely born from the thermodynamic arrow, the statistical, irreversible increase of entropy described by the second law. These are not mere speculations. They are the frontiers of physics, where our classical intuitions break down and a more subtle, complex reality emerges. It is a lot for the waking mind to hold. So as you prepare for sleep, you can let it go. You can allow these concepts to decohere, much like a quantum state settling into a definitive reality upon observation. Let them spread out into a soft, uniform haze of wonder. The goal was never to provide a definitive answer, but to gently relax the rigid frame of classical time, to loosen the certainty that keeps us fastened to worry and regret. For if time is not the external, universal constant we perceive, but a relational property that emerges from quantum correlations and the increase of entropy, then this present moment, this neural processing of sensory input you are experiencing right now, gains a profound new significance. It is the only valid reference frame you truly have. The past is a reconstructed memory, a pattern of synaptic connections firing in your brain now. The future is an anticipatory model, also running now. The present, this silent, spacious now, is the only domain of direct experience. And what a physical system is at work to create this experience. Right now, as you lie there, the planet's rotation carries you through space-time. The solar system orbits the galactic barycenter, and the galaxy itself moves within the local group. And yet, in your inertial frame of reference, you are perfectly, completely at rest. Because motion, too, is relative, a fundamental tenet of our journey. You have chosen the most peaceful reference point of all, your own center of mass. The moon, that gravitational companion, continues to exert its tidal force, transferring angular momentum from Earth's rotation to the moon's orbit. Somewhere, a wave is lapping at a shore, and our planet's spin is being imperceptibly slowed, stretching the length of our day. The universe is in motion, governed by physical law, but it is not in a rush. It is a slow, graceful, deterministic evolution. So, what is the physical state of the storyteller who falls asleep? When your conscious mind, the complex neural network that binds sensory input into a coherent narrative, begins to disengage. The universe does not vanish. The quantum states remain. But the integrated information theory of consciousness suggests that the level of integrated information, the phi, decreases. The experience of a linear narrative dissolves. In the slow wave sleep of NREM stages 3 and 4, the sense of a temporal continuum may well fade. You return for a few hours each night to a state that is, in a sense, more aligned with the timeless background of the universe. A state of pure physical process, unobserved by the self. This is the most profound implication of this scientific exploration. It grants a permission to rest, grounded in physics. Permission to let go of the relentless entropic drive that fuels the day, to release the anxiety of time's arrow. It is not slipping away. You are moving through a configuration space, and you are allowed to pause. Sleep is not a waste of time. It is a necessary thermodynamic reset, a lowering of your local entropy through the expulsion of metabolic waste and the consolidation of memory. You are not escaping time. You are engaging a vital biological process that sustains the very system that perceives it. The dinosaurs existed within this block universe. Ancient stars fusioned their hydrogen within it. Their existence is a permanent world line in the space-time manifold. Your life, too, is a world line, not a fleeting one, but an eternal fixture in the geometry of existence. The moment of your birth is a fixed coordinate. The moment you feel right now is a point on your world line. It is always and only now. So as the synaptic rhythms of your brain begin to synchronize into the slow, high-amplitude waves of deep sleep, know that you are not losing consciousness. You are shifting your interaction with the universe. You are allowing your biological system to recalibrate, aligning its internal state with the deepest, quietest physical laws of the cosmos. The worries of the day are receding, not into the past, but into a different set of neural pathways. And the universe is complete and lawful, and you are a part of its structure. Wherever you are in the world, whatever the hour, may this physical reality cradle you. The universe evolves according to its initial conditions and its laws. The stars are not anxious. Time, as a parameter, is patient. It will be here when you wake, a ready variable for your brain to once again weave into a story. But for now, let it go. Surrender to the thermodynamic imperative that your complex system requires rest. Right now, in this room, in this bed, you are a physical process, obeying the same elegant laws as everything else. Good night, time traveler, and we will meet again in our next journey.